Hello students, I am Sanap K.B from Department of Physics of RBNB College, Shrampur. This is my fourth lecture on the topic number 10, magnetic fields due to electric current. In previous lecture, we saw about the force produced by magnetic field. Considering to that different current carrying wire such as straight conducting wire, arbitrary wire and closed loop circuit wire, that forces already we obtained in previous lectures. Now today we are going to next article from this topic is torque on a current loop. You know, the two important concepts concerned with physics is a force and torque. If motion is a linear, that is in a straight line, then force affecting on it, and if motion in a rotating motion or circular motion, rotating motion, then new concept is there, torque. What is the definition of torque or how to find the torque? Torque can find that magnitude of one force into moment of a arm or perpendicular distance between that two forces. Now torque can produced by one force or it is also produced by two forces also. You know that production of couple, here for the couple that equal and opposite forces are acting on a body, then there is a formation of couple and torque acting on that body and that body rotates. Okay. Now this principle is used in a electrical motor. You know the construction of electric motor. Here a rectangular conducting wire is placed in between two magnetic pole pieces, that is N and S. When current I flowing through this rectangular conducting wire and magnetic field is affecting from or acting from N to S pole, then that rectangular coil rotate along this direction, and now it will be rest some time when these two forces acting on it and then couple produced. Now here this is the direction of magnetic field from N to S, and now current will be flows through this rectangular coil will be this one. Both are perpendicular to each other. Now here consider that rectangular coil is here, magnetic field. This symbol indicate that field is perpendicular and in outward direction. So this is a magnetic field which is in a outward direction. Now here consider that rectangular coil here, that is A, B, C, D. This is same coilage having length L2 and breadth L1. Okay, L1 is the breadth of that rectangular coil and L2 with the length of that rectangular coil. Now here magnetic field directed in outward direction. Now according to right hand rule, that pointing figure at right hand show the direction of current and the middle finger shows the direction of magnetic field B, and the stretched thumb indicate that the direction of force, that is a force produced by magnetic field. This is Fm and this is again Fm. Directions of that forces are here. That can be explained by right hand rule, again PAM rule, that can be explained both the directions of these forces produced by magnetic field here. Now here magnetic field produces the forces on that rectangular conducting wire, that is a F1, F2, this is a F3 and F4. Okay, now these two forces are parallel to that magnetic field and they are equal and opposite. Both these forces are cancelled to one another, and now only these two forces, that is F1 and F3, acting on that rectangular coil, and they forms a couple. Okay, these two forces are separated by some distance L2, and these two forces F1 and F3 produces a couple. These are directed in opposite direction, but they are not act at a point. Their actions at different points, and therefore there is a formation of a couple. Okay, now see that figure number 3, side view of loop at an angle theta. Now that force, that is F2 and F4, these forces are equal and both are cancelled to one another, and that value of that F4 and F2 is equal to that current I L2B sine 90 minus theta. Now these forces are here cancelled to one another. Only that force F1 and force F3 are acting on that rectangular coil, and magnitude of force F1 and F3 on that side AB and side CD will be that force is given by IL1 sine 90. That force is given by IL1B sine 90. Now this value of sine 90 is 1, and that force will be IL1B. This is a magnitude of a force. On that side AB and side CD, and now these two forces do not act along the same line, and hence they produces a net torque. and this torque result into rotation of the loop, and ह्या torque that rectangular coil rotate along that direction, and we have to obtain that torque on that current loop. The moment of arm is given by 1/2 L2 moment of arm is 1/2 L1 sorry L2 sin theta is there. L2 sin theta, that is a length of that rectangular wire. Now torque due to forces F1 and F3, that force F1 and force F3 produce a torque will be, that torque will be tau is equal to that force will be I L1B into that moment of arm, that 1/2 L2 sin theta. Now then plus I L1B, that 1/2 L2 sin theta. Addition of these two forces, and that value comes to be I L1 L2B into sin theta. Now this is a net torque acting on that rectangular coil. Now if this rectangular coil is made up of multiple wires, that is n number of turns, then torque for that n number of turns is given by n into that 2 already we obtained here, and now that torque is equal to that n into that L1 L2 B sin theta. Now here L1 into L2, that will be length into breadth of that rectangular wire, and that is the area of that rectangular wire, and therefore that torque is equal to NAB sin theta. This is the required torque on a current loop. In this way, very simply, we can obtain the value of torque on current law here. Explain this figure here. Consider the rectangular coil ABCD is placed in between that two pole pieces, and now that L be the length of that rectangular wire or that coil, and L2 be the breadth of that rectangular wire. And now magnetic field is affecting on that current flowing rectangular coil, And now force produced by magnetic field FM is directed by the right hand rule, that is a right hand rule or PAM rule. Perpendicular term indicate the force produced by magnetic field through this conducting loop, and that force is given by, you know, that I B sin theta या स्वरूपामध्ये आपण हा फोर्स कॅल्क्युलेट केलेला आहे. And then that force for that particular cases are like that one, that is IL1B. IL1B is a common this force. And then considering that total torque acting on that rectangular coil is addition of these two torques, L2 sin theta, L2 sin theta, consider to that figure, and then taking the addition of these two, we get the torque toe is equal to this form, I into L1 L2 B sin theta. Now this rectangular coil is made up of multiple coils which are n numbers. Then torque for that n number turned coil is given by that toe dash is equal to n toe. Put the value of that torque here, and now equations becomes that one, where L1 into L2 get the area of that rectangular coil. Then toe is equal to NAB sin theta is the net torque on a current loop. Now in this way we can easily find the torque acting on a current loop. Now we can stop here.